This is problem 25 at the end of chapter 3. Find the speed of a lunar orbiter in a circular orbit that is just above the surface of the moon, given that the orbiter's acceleration is equal to the moon's gravitational acceleration, 1/6 that of gravity on Earth, in other words 1.67 meters per second squared. Here is a sketch of the situation. This center dot is the center of mass of the moon. The R is the radius of the moon. The lunar orbiter is going just barely above the surface of the moon, so it's going essentially at the radius of the moon. That's what we'll use for R in the problem. If the velocity is tangential, as I've shown right here, the orbital velocity is tangential and it's executing circular motion, uniform circular motion, then that means that at any particular point in the orbit there will be a centripetal acceleration, as shown here. That from chapter 3 material is the tangential velocity squared divided by the radius of the orbit, and that's going to equal to the centripetal acceleration, which we're told is equal to the gravitational acceleration of the moon. So I can solve that equation for v squared. V squared is equal to r times g sub m. V is equal to the square root of the product of the two. In for r goes the radius of the moon, and in here goes the gravitational acceleration of the moon. Check your units inside the square root, meters squared per second squared. Square rooting that gives meters per second, which is what we end up with here. In meters per second it's 1705, and converting that to kilometers per second it's 1.71 kilometers per second.